So, welcome to the Technical Leaders Forum on Smart Instrumentation and Control. We have kind of been hit by coronavirus in the fact that most of our panel has disappeared. So this is going to be a bit of a two-man show, so I am going to rely on audience participation. If there is no audience participation, I will grab somebody from random from the crowd and get you to sit up here with us. So, my name's Grievson. I am the technical lead at ZTech Control Systems, and I'm also the executive director of Water Industry Process Automation Control. I'm a bit of a smart water instrumentation geek, and to be honest, this has been kind of heaven for me over the past few days, seeing the digital twin for Valencia and everything, and it's highlighted to me the importance of instrumentation. Those of you who came on Monday saw that instrumentation was the fundamental basis for a digital twin. We have to get it right. We have to get it in place, installed correctly. We have to know the uncertainties of the instrumentation that we install and feed that into the model. I'm joined by, do you want to introduce yourself, Pablo?
Yeah, sure. Well, I am Pablo Alcoriza. I am technical product owner of the GoIWA platform. I think you've heard about GoIWA these days at WEX. It's a software platform being the main product used by Integra for offering water services around the world internationally. And, well, I'd like to have more mates in the panel, but I think it's going to be okay. We don't have much time either, so.
We don't. So do you want to come up here and, sure. I know you've got a slide, so cover it.
So, well, thank you, Oliver, for this introduction. Thank you, WEX, for hosting this panel, for inviting me to give this brief talk. I hope you don't get very bored. I think it's going to be, I hope it's interesting. I have a feedback of software development for many years. So when talking about instrumentation and control, maybe my point of view is a bit different from a hydraulic person or a technician. So I hope I can give you some point of views of what you should consider before selecting or choosing a sensor, and why should you use them or not use them from that point of view. And I remember yesterday Oliver was asking me, what is a smart sensor? And well, that's a tough question. If I had to briefly say what it is, I would say it's basically a set of meters which are attached to a microcontroller or CPU, able to execute some complex logic and also to be integrated with other high-level software systems and control systems. So we are surrounded by them, basically. Here you have a couple of images. That's an Amazon Echo, and that's a Raspberry Pi. So you could consider that those are smart sensors in the sense that they are intelligent. They can measure things, they can react to inputs, they can have complex logic implemented inside. So, but in the water industry, we've been using for many years, and also in other industries, PLCs. So isn't a PLC a smart sensor? Well, it in fact can be very smart. I mean, PLCs, many facilities can be automated by implementing logic in PLCs and automating control and processes that happen inside the facility without the need of external intervention. But it's true that a smart sensor, if we think about it, or at least it's how I think about it, it's very related to IoT sensors, which are able to measure things in definitely very interesting scenarios. Here you have some inputs, or where would you use a sensor, a smart sensor, able to measure and activate against infrastructure. So you probably have some scenarios where the lack of power is a must. You cannot plug something to a power network. You need wireless communications. There has been wide range of new radio protocols, LoRaWAN, Narrowband IoT, aside from 4G, wireless, coming out for the last years. Maybe there are non-critical applications where you can have this kind of sensors, small pieces of hardware that can take measurements at a low rate, and you don't need them to control some critical infrastructure. Of course, budget is something you can take into consideration, but we'll talk later about budget, because once you start, from our experience, I will talk later about the experience of Global Omnium and GoIWA. It depends, really depends on what you are asking the sensor to do. It can be very cheap or it can be really expensive, depending on your demands. And also modularity, most of them are like plug and play pieces of hardware, where you can just plug a sensor, remove a sensor from the whole equipment. And also you can perform their edge computing, basically because traditionally you have, of course you have a programming tool for programming how a PLC is behaving, but a PLC is more like a microcontroller. And in IoT devices and smart sensors, you can use more advanced programming languages to make things where the sensor is. Look, you can use C#, you can use Python, you can use other languages which are more advanced than you could find in a PLC development environment. So I would say, yes, definitely they're an alternative, and they fit very well for certain scenarios where a PLC is not suitable for any of these reasons and many others. The problem may be which one you choose. And that's a major concern when I've been participating in this type of projects where we want to do this thing and we have a limited budget, we cannot use a PLC, we cannot afford contracting provider for programming all this stuff, the hardware is too expensive. So let's place some smart, cool sensor that measures a lot of things and send it to a platform and we can gather the data. So then the next step is which one you pick which one you pick. There's so many manufacturers of IoT devices, so many manufacturers of smart sensors. Additionally, many of them are coming together with their own software platform. That means that you're not only buying the device, you're also buying a software platform the device is connected to, and where the information is lately going to be for you to get it and use it. And that's also something you should consider. So this doesn't mean that there are no options. Of course there are options, but it really depends on your criteria, what you demand. We'll talk about that later. There's another option, of course, you can build one. This is a field where there's a lot of hype because I've met many startups which basically are building IoT devices, smart devices for doing things. And the state of the art right now with all this technology is that everybody thinks he's doing something unique, something that is not repeated anywhere in the world. And that's dangerous because there are so many open platforms over there. You can think about Raspberry Pis, you can think about Arduinos, you can think about so many frameworks that going into building something for you by your own is, you must be very sure of what you're doing. So, but I say this here because Global Omnium has taken both approaches. They've used already existing commercial products for smart sensing, but they have also started projects inside the Global Omnium Innovation Hub for building specific devices to make 13 things. So whether you decide to build one or buy one, aside from the cool aspect of the sensor and some other considerations, at the end of the day, you have to think about all these things. Which is the supply chain of that sensor? What means, what happens if that breaks? If it's broken, how much time until you get another one? to put it on field, which is its life cycle, because it's, this is a very open source kind of technology with frameworks available for everyone, which means that iterations are very fast. You've been using maybe a sensor today, and in 8 months, 10 months, you have the next release of the sensor with more capabilities, with bug fixes, with a lot of things additional, and you're getting obsolete very fast. It's not a PLC, and that means that its firmware is very important, because if you buy a PLC, the firmware it comes with, it's tested for many, 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 many years. I mean, it's a very robust device. Maybe the software you're programming inside the PLC is wrong, and you have made some bugs or some mistakes, but the system, the operative system of the device itself is really stable, and that's something that can be a bit of concerning regarding IoT devices and smart sensors, which are new, because some of them are based on Linux distribution, some of them are totally new, built from the ground up by the manufacturer, and that means that you may need firmware updates along its life cycle. And that's not easy. You can find some devices that can be updated over the air, which is like our mobile phones just update new iOS version. You just say, okay, install. But that's not a typical scenario because it requires the sensor to have special capabilities. Budget, of course, is something that you should take into consideration. Basically, because when you think about, well, what do I want this smart sensor to do? You start writing a letter of intentions, and you say, well, I want to measure temperature and humidity, and that's okay. And then you start thinking about, well, which is the data acquisition rate I want? Maybe I want it to be fast acquiring data. But then you need a bigger battery if it's going to run alone. And then you need a specific radio communication protocol because it's going to be installed somewhere in the mountain. And then you need local storage with an SD card because you want it to lock in case it loses communication, and you can send it later to the system. So that means that once you start enumerating things, it's not as cheap as you may think compared to other things which are already a mainstream in our industry. Of course, communication and security. I think the market is moving to an online paradigm. Everything is connected. The Internet of Things is something we should be concerned of. And these devices should meet some minimal requirements. There are in Spain, and for sure around the world, some telco companies are certifying these kind of devices in terms of security. There's no breaches, they cannot be hacked, they cannot be accessed without easily, and all this stuff. That's very important as well. Also, programming tools, how do you program them? How do you put inside of them what you want them to do? Is it possible or not? It depends on the sensor you choose. Of course, you need integration, which means we've been talking about WEX, about digital twins. Oliver was saying before, digital twins, data integration. That's a must from my point of view. Like you have to go, or at least that's our view. It's not possible to integrate sensors that rely on a manufacturer solution with no capabilities of data being open to other platforms. I mean, you need some kind of API to bring that sensor data into your cooperative systems, because otherwise you're going to start building data silos again, but now the sensor is cooler than a PLC. But it's a data silo anyway. So one of the things that Global Omnium is doing from like 4 or 5 years up to now, it's assuming it's going to use a sensor as far as it can integrate to its cooperative systems using Web platform, which require this integration is not really a very heavy integration, but you require some things like it can transmit data to our systems, And in case I want to control it, there's a feasible way to do it, like sending an order or capture an alarm or something like that, okay? Criticality, of course, is also very important, like how critical is the process you want to control. And also people, because at the end of the day, once you start installing these pieces of hardware and these systems in your company, you need skilled people to manage them. I mean, we are not anymore in the PLC world where you can just call a contractor and say, come here, please, and make this modification, or you call, I don't know, Schneider support or Siemens support, or whoever support, and you will find many companies that can give you the service. When you go into a smart sensor, you must take in place that the people working in your company should know how it works and should care about how it works, because probably they're going to have to make some maintenance, reprogrammation, all this kind of stuff, installation, because we're talking about a landscape where there's so many that you really have to study, and it's something that happened in Global Omnium as well. In our experience, at least I can talk about what's happening mainly in Global Omnium. We have other customers that are also doing these things, but they're being used for mainly flow pressure, temperature, and water quality monitoring, especially in places where you cannot bring a PLC there because it's maybe somewhere in the middle of a city with no electrical power, all these scenarios. Remote locations, complex behaviors, because that's one of the cool things you have with a smart sensor, depending on how the sensor is, but you can have very complex logic being executed in the sensor, because you can use advanced programming languages for that. We've been doing proofs of concepts with several commercial products, and we've also done some project development inside GoHub with some of the startups over there, and making some tests, deploying them, monitoring their behavior, integration capabilities, and all this stuff. And also, of course, always asking the device, no matter how cool it is, but you have to integrate with their higher level cooperative systems. Because when you're talking about advanced analytics, Water 4.0, digital twin, all this kind of stuff, that device should be integrated into your systems. So if it can't be integrated because of any reason, I would say it's not suitable. Because at the end of the day, unless it's a very specific application that should be managed locally by a specific group of people, and the information happening there is not valuable for a company as a whole, it may be right. But we tend to a scenario where everything should be promoted to a higher level of software implementation, to a transversal platforms for the company. So, and another lesson that we learn is that failure comes before success, of course. There's no silver bullet when you're trying to implement this technology in your company. And you're going to fail, of course. But you have to experimentate as well. You know, the first thing that comes to my mind is, you know, that Global Omnium has a very wide park of smart meters, household smart water meters deployed around 800,000 more or less. And it's been a long way until reaching the good technology, the good manufacturer, the good device that could be used in a reliable manner. So, and there have been many failures in the way, and many headaches in the way until we picked up the good one. And the same happens with other kind of smart sensors you can think about. So, final thoughts is that I would say that this type of sensors and instrumentation are here to stay. Basically because they are pushed by also major PLC manufacturers and telcos. Like, you can already find some smart sensors in the IoT way of the term from Schneider, from Siemens, from some very big companies. Google, Amazon, all these kind of very big telco companies are pushing the use of these type of sensors. And they're definitely going to stay here for a long time. I would say that the supply chain and the manufacturer health is a must that you should check before choosing one. because you can have a very big problem in the midterm in case you don't make a good decision. You should enumerate your needs. What do you need the sensor to do? How much does it cost? And compare to other solutions you're already using. Very important from my point of view is you should ask IT for its requirements. We're moving to a scenario where OT and IT are not separated anymore. Or at least they are converging at some point where there are some discussion about these things. Water utilities are full of systems where I've seen some people asking IT for support, and they said, well, this is a SCADA system, I have no idea how it works, you should ask OT. And this should not be like that anymore. We're moving to another scenario, and IT has a lot of requirements for security, communications, data integration, and scalability of the system. So it really does matter to have their opinion. Always consider integration with higher level systems, specifically, of course, non-manufacturer platforms, because of this thing I said before. Like, of course, you can have a manufacturer platform for maybe managing the life cycle of the device or a sensor, but the data it's measuring, you should take it away from that and promote it to another platform, database, wherever you have in your company. And don't forget that PLCs exist. They are as cool, as fancy as these smart sensors, but this has been around the industry for years. And what happened in the PLC manufacturing industry is that because of the appearance of these smart sensors, these IoT devices, the PLC pricing has been decreasing around the last 4, 5, 10 years maybe. And you can have the first entry point in a PLC technology is really cheap right now. Probably not as good as you need, but you can find some good things for a really reasonable budget. And I think that's all.
Thank you. So, any questions? And to me, it's getting that IT-OT convergence. We're seeing it in some companies, but you see when they do get just brought together in a lump, they don't necessarily speak the same language. They'll have the same words for two completely different concepts. So how do you get them working together?
Well, that's a good question. Well, it's really. I think it really depends on who can push this convergence is the general management of the company. Mm-hmm. Definitely, because one of the main things that happens with this kind of sensors as well is that the data they're producing and the systems that you use to control them are not local anymore. They are not placed in a Windows PC somewhere in a water treatment plant that only OT can access that PC to see what's happening in the facility. This is promoting to a higher level in the company, and that always I think it's tough for the OT department. Mm-hmm. Because they feel like they're losing control of what they're doing, or they're going to be under, they're going to be, someone's going to be looking all the day, what are they doing and how are they performing, and that's reasonable. OT is in a water utility is concerned about making the facility work, mm-hmm. and that's absolutely right. But from the business case, you really need to make this data come up mm-hmm. to your cooperative systems. And that makes that data visible. So who can make OT really participate in this is probably general management, I would say. That was the case in Global Omnium at least, yeah. And in other customers that I've found as well. Because the general manager has the vision to make the company smart, data-centric, and that definitely needs that OT and IT speak. Maybe not the same language, but they just have to agree on some points. So before doing something, before deploying something, before buying any system, just to take into consideration each perspective.
The concept of data centricity is something I've heard quite a lot over the past few days. And yes, in a lot of companies we know there's lots and lots of silos, and some data from a proprietary manufacturer won't talk to another system, and trying to all get all the different systems talking almost seems like an impossible task. What would you be your advice in terms of to a company who's in that situation? Is where do we start?
Well, I would say for the things you already have there, you should check if you have. I would differentiate two scenarios, like SCADA systems or systems controlled by PLCs and other type of manufacturers or systems. For SCADA systems, you can use different industrial standards to communicate with them. And most of them, although it's hard, you can take data from them and promote it. Like we are using, for instance, in our software platform in Guayua, we are using OPC for this, which is an industrial standard for many years, to extract data from this system. And that means that and it's a very feasible way because you can extract data from that system without really bothering the system itself. So it's not going to stop working because you're getting data from it. In the other case, like manufacturer solutions for specific devices, I would say you should check with the manufacturer if they have some kind of API or open database to access the data. And once you have the overview, you should put a platform above and define how do you want to integrate. There are commercial solutions for that. GoEye was one of them, and we have a very good experience with Global Omni and other customers around the world. And but you just really, this is the first thing you should do maybe. Like ask IT to make some kind of inventory of what we have. What do they know about those systems? Do they know if they have an API, a database? How we can extract information from there? And that's great. I mean, it's not a matter of replacing something you already have with another thing. So the effort should go into taking profit of what already exists, and just in case it's not possible by any other means, then you can think about buying new instrumentation, additional instrumentation for a facility to monitor certain things you want to monitor very specifically.
Doing the gap analysis type approach.
Exactly.
Finding out where your data gaps are, and I suppose that comes from the information strategy.
Sure, for sure. Yeah.
So, any questions? Yeah.
According to my experience, 95% of utilities still use 420 milliamps input to their SCADA system. Maybe some use Modbus, and I think we had one request for an API in order to transfer the data. So the 95% is still
95% is still 420 milliamps. So the provider of whatever sensor, in order to feed the data into the SCADA system, needs to provide a 420 milliamp signal output.
Sure, yeah. Well, in that case, I mean, you're connecting that sensor to a PLC at the end of the day, so to one of the analog inputs of the PLC. And then you can connect to a network of PLCs deployed in a facility, or if you have a SCADA system already controlling them, you can connect to that system using some industrial standards. So it's okay the sensor is that way. It's okay you have Modbus, of course, is also very useful. You can connect, it's a standard, industrial standard. So that also happened in Global Omnium as well. Most of it is built using PLCs, and instrumentation is based on 420 milliamps and all this stuff. But you can, I would encourage the use of OPC, because it's what it is. It's basically a protocol managed by the OPC Foundation, which is an international foundation. that aims to standardize the way you talk to an industrial device. Because when you buy a Schneider, you have a protocol to talk to the Schneider PLCs. When you buy Siemens, you have a protocol to talk to Siemens PLCs. When you buy Omron, Rockwell, Honeywell, it doesn't matter. Everyone has its own protocol. So OPC is a way to talk to those devices using a single language. How do you do that? Here comes in the game a specific software called the OPC server. An OPC server is basically a software that implements a set of protocols for different manufacturers and devices in one side, but on the other side only speaks OPC protocol. So that means that you can connect to those PLCs using this software, and then you can talk to that server to ask for information in any of them. So I don't know if I'm answering your question more or less. That's how we encourage.
It wasn't really a question, let's say, I just put it the other way around. As a supplier of a sensor, I have to comply with the needs of the utility, whoever's going to use it, and most of the utilities still use 40-20 milliamps, and then they have this additional line for the additional sensor, and then it's in their visualization tool, their decision-making network, whatever. So it's not for me to choose what they use. It's hard enough to sell a sensor to them.
Yeah.
I'm not going to change their SCADA system or their decision-making system in the utility. So,
but from my mind, yeah, I've seen. I agree with the 90. I'd say greater than 95% are on some sort of 40-20 milliamp. Okay, some may be on Profibus. But actually, to be honest, I think it's all that certainly most water industries can cope with. I mean, there's this wonderful new protocol that's being used quite a lot now. It was invented 40 years ago, the HARP protocol. And I'm finding that the water industry in some areas is just discovering the HARP protocol. We talked about Modbus, and that's got to be 1970s.
yeah, but it's
still used, and it's still perfectly valid.
They have operators on the ground. They are able to measure voltage or milliamps, and if anything breaks down, they just go there. They can measure. They understand it. They fix it. As soon as you introduce any kind of protocol or digital technology, they are lost because they have no idea how to fix it. They cannot even find out if it's working. That's the the real world problem, and that's why 4-20 milliamps is so sustainable, because everybody's able to understand it, everybody's able to fix it, and it's just easy to keep it running. So I think that's the
but again,
background.
The majority of sensors don't have to be smart. The majority of sensors in most water companies are level. All you want is that 40-20 milliamp measuring the level. Job done. Yes, in some areas you're going to have multi-parameter sensors doing all sorts of smart things. In those sort of situations, 40-20 probably isn't applicable. But then you've got GSM, GPRS. You're not going to have the Internet of Things protocols because the bandwidth isn't big enough.
Sure, I agree. Of course, 4-20 milliamps perfectly
absolutely
okay for a level sensor. And if you have a more modern sensor, most of the time you lose a lot of information if you just convert it down to 4-20 milliamps. And it's only one way. So that's another problem, because most modern sensors, you can talk to them, but not using the old technology. So it would be good if there would be a transition and a change in the utilities, but I think it's a hard work to convince them or to educate them in a way, or to provide a technology which is as easy to maintain as the old 4-20 milliamp thing.
It's a tough transition. Also, I can say I'm still saying Windows XP computers running a big water drinking plant facility. So that's a type of tough transition. But I think it's normal. I mean, I don't blame the customer that is still in that situation, because that's a critical system. So innovating or changing things is really a tough task for them, and dangerous somehow. And that's the reality. And in the case of sensing, I think it's a matter of time. It's probably a matter of time. Maybe water sector is, we could think is very traditional in that way, but you should go to automotive or any others and see what's going on there. Big companies, monster companies doing things with very old legacy systems. They don't want to change because it works. And
some tried to change, some changed, and then they changed back.
Yes, yes. That's because, I mean, investing in technology is it's tough. It's not easy. It's very difficult, and you have to be. I think the previous panel was talking about this. Like, you should have a small piece of your budget to invest in technology, to try technologies, make proof of concepts, try to improve. You can choose not to improve, of course, but at some point others will. And if you do not improve and others do, you lose your business.
Yeah, but somebody would have to offer those utilities a safe way for this transition. I think they would never just switch off the old system in order to try a new one. Sure. They would have to have two systems in parallel, and then as soon as they're convinced, they can turn off the old one, but they will never get rid of the old one and just have a new one, because it's just not feasible, safe enough for them.
At that, unfortunately, far too short a discussion. Penny's wildly signalling me to wrap it up. Thank you very much for coming to this shorter session, and I believe we're going to be handing over to Jim.
Very briefly, just to thank Oliver and Pedro. As we've seen, we've just had 1/3 of a panel, but with the quality of Pedro and Oliver, who are 3 times better than the average panel member, we've all had value for money. So at the end of the day, it's been a very good session, illuminating for me that particular session. I've been in the water industry well over 40 years, and in the days when 420 milliamp was the standard at the very beginning, with pH meters and a range of meters, and we're still having the same arguments. So things sometimes don't change, but I think the industry has advanced tremendously, and I think we've seen that over the last 2 days. I've certainly been very impressed, and I think this time round, and again, we've had the opportunity to catch up with the industry, catch up with colleagues and friends, people that we've known as part of the WEX family, all of which makes for a very pleasant environment in which we can all learn and understand more about the sector. I think this year we've gone around the world again. We have gone around the world, but 1 year has advanced since we were here or at the WEX event a year ago. And in that time, it's very clear that the industry has changed significantly. For me personally, the WEX event last year was maybe a more practical event. This year, digitisation has been a very key part of the discussions. It's been instrumental in probably most of the panels. It's featured throughout the event, and it's telling me that WEX is at the leading edge of the industry, which is why it's always good to come back. It's refreshed every year, and we hear and listen to new things every year. So important to, I think, keep abreast of what's going on in the industry. Good to be here, and I'm thinking next year we will be around again, I haven't got the details for next year, but I'm sure Mark will be circulating those. And I think we should have, I'll be looking forward to another very enjoyable event next year, irrespective of coronavirus, which I hope, which in 12 months' time will have dissipated to the point where it's non-existent, or at least it's in the background and doesn't cause any concern for people wanting to attend the event. I think we all understand that it's important for people to follow their corporate advice. Some people have been instructed not to attend. I have no corporate advice. I make my own mind up. I am very fortunate. I don't have anyone telling me what to do. I just want to carry on business as usual, which is what I've done. And I think most people have also taken the same view as well. So finally, to take the opportunity to thank everyone, particularly Mark, in the midst of changes to panels, restructuring of the programme, rescheduling of events. The truth is, it's been a really remarkable WEX event again this year. And I think testament goes to Mark and his team to ensure that the event that we've had has been, in my view, just as good as any of the events we've had in the past, irrespective of attendance or attendees. It's been a really great event, and I'd just like to ask for a round of applause for Mark and his team. Thank you, Mark. So, nothing more to say, really. I stand between people in the audience and lunch, and I'm sure that's not the most pleasant of situations. My stomach is already rumbling. It's been a long time since breakfast. It now just remains for me to say, everyone, please have safe travels home, return home, and hope to see most of you, if not all of you, next year. Thank you very much. Thank you.